Good afternoon, boys, and I'm sorry I can't be with you today, but it seems I am kind of here, doesn't it? Okay, so today I want to move on to parallel and perpendicular lines. At a key moment in this presentation, someone will need to press pause so that you can do the questions I ask, and then you can move on after that. So firstly, I'd like to talk about perpendicular lines. Now, one line is perpendicular to another line if it crosses that line at right angles. So here's an example here where I've got a randomish line there, and you can see that the other line is crossing at a right angle. We say that that is perpendicular. That line is perpendicular to that line. Also, the converse applies too, doesn't it? Okay, now this is a key fact that you need to know. If a line is perpendicular to another line, then its gradient, which I'm calling M2, the second gradient, will be equal to that there. Okay? So it's easy to find the gradient of a line that is perpendicular to another line as long as we have that other line's equation. So, put quite simply, if a line has a gradient of 2, any line perpendicular to it will have a gradient of, here's the working out here. So we substitute the 2 in there, and we can see that the gradient of any line perpendicular to a line with a gradient of 2 will be negative 1/2. Okay? So, that's a key fact. Now, let's have a look at an example. I'd like to find the equation of the line perpendicular to the line given by this equation, x minus 2y plus 3 equals 0, that passes through the point 7, negative 2. Okay, here's how we go about it. Firstly, we're going to need to put our original equation into the form y equals mx plus c. So that just involves rearranging our equation. So let's have a go at it. Okay, so we're saying this is the original line, x minus 2y plus 3 equals 0. Our job here is to put it into that form, so making y the subject of the equation. A good first step would be to subtract x from both sides, so therefore negative 2y plus 3 equals negative x. And the next step would be to subtract 3 from both sides. And then to divide both sides by negative 2. So y equals negative x minus 3 on negative 2. Now, that's a bit messy in that form, isn't it? So what we can do is divide top and bottom through by negative 1, or times it through by negative 1, doesn't matter, it has the same effect. And so we can do that, and all that does is really change the signs so that it's easier to understand. Now boys, you should understand this as well, that another way of looking at that equation is that everything upstairs is divided by 2. So really, that's what we're looking at. Okay? And so you can see, I hope, that the equation of our original line here is the coefficient of x, which is 1/2. So we'd say, therefore, m1 equals 1/2. Remembering, x divided by 2 is the same as saying 1/2 times x, isn't it? Okay, now I've got to find the equation of the line that's perpendicular to that line and passes through that point. So far, I don't even know the gradient, but we do know that m2 will equal negative 1 on 1/2. Now, when I divide a number by 1/2, it's the same as timesing that number by 2, isn't it? So m2 is going to equal negative 2. Okay? m2 will equal negative 2. And now I've run out a bit of room. So what I'm going to do now is go to the next slide and work with this information here. So we've done that sort of thing in the previous lesson. What we know is that the gradient is -2, and whatever the equation of the line is, it's going to pass through the point which I think was 7, -2. Okay? Now remember, the go here is to try to fill up or substitute the missing values for m and c into our gradient intercept form of the equation. Well, I already know m, don't I? We call it m2, but we're substituting it here, so it's -2. Okay? So y equals -2x plus c. What I need to do now is find a value for c, and remember, I can do that by substituting a coordinate into my equation so far. Remember what this is saying? It's saying that when x is 7, y is 2. So quite simply, I substitute y equals 2 into there, and x is 7. Sorry, I thought one of them, yeah, that's a -2. So, -2 equals -2 lots of 7, substituting the x coordinate in, and it should be a simple enough matter to find the value for c. So -2 equals -14 plus c, and therefore c, adding 14 to both sides, equals 12. So what I know at this stage is that y is going to equal -2x plus 12. Now, that answer is not totally satisfactory. I don't want to flick back because it can take some time. You will have noticed that the equation was expressed in general form. So I must rearrange my equation so that it's in general form. Basically, well actually let's have a look, maybe it won't take long. Oh, there you go. X followed by y followed by the constant. Okay? So, let's have a go at that. That would mean adding 2x to both sides. And finally, subtracting 12 from both sides. And now I've got it in general form, which is your equation set to equal 0. Now what I'd like you to do right now is pause the tape and have a go at plotting those two lines with that coordinate shown. Okay? So, press pause please. Alright boys, have a go at this question now. Using the same equation, I'd like you to find, the one we just looked at, the equation of the line passing through not -7, 2 anymore, but firstly the origin, which is 0, 0, and secondly 4, -2. Okay, so that's the end of that little tape. You might want to pause it now, and there'll be another one to look at once you've finished those two.